like a template of writing for loop. There are three types of for loop that we want to consider. So here we are talking about templates for the syntax for for loop. So the first one is the traditional for loop. So for the traditional for loop, it's like this. You write for, you will write the, you will initialize initialization. You are going to initialize the variable that will be repeating the variable for the task that you want to be doing. Maybe you want to count 1 to 10, you want to print 1 to 100, you want to allow people for admission. So anything, the task you want to do, you are going to initialize it. You are going to tell us the first value of that variable, where that variable is starting from. So that is initialization. Then you are going to tell us how that task will terminate, the number of times. It talks about the terminating condition, how it will terminate, so that you don't continue to run this program forever. When you don't have a very good terminating condition, if your program does not terminate, it continues to work on your RAM. So that the program will be running forever until you manually stop it. So then you have the modification. So modification is about increment and decrement. So you have to modify. You start, you have an initial value. So you will have your initial value. Then you are going to modify it to move to another value, so that you are going to be able to move to another iteration. So in initialization, for the first execution, initialization will be done. Then determinating, or we will check the terminating condition. You will check the terminating condition, but you will not modify for the first iteration. So when you now want to go to the second iteration, you will start from modification. You will modify the current value. You will increase it or you will decrease it depending on the type of problem you are trying to solve. Then after that, you are going to check the terminating condition. Then you go into the loop again. If the terminating condition is satisfied, it is true, then you will go into the loop again. So it's only once that you are going to consider this initialization, and it's only after the first execution, first iteration, that you are going to consider modification. So the statement that you want to execute, or the set of statements that we want to execute, will be inside the for loop, then behind it. So this is the template for the traditional for loop. So now let us talk about, there's another for loop that we call, that is for loop with break. We also have for loop with break. So for loop with break is the way it works. It's still the same expression for initialization, terminating condition, and modification. So you still have them like this. So you will still have them like this. So you become this way. But in this case, we have with break. So that break, it is working just like the break of switch case, and it will make use of if. So this if, we also have a condition attached to it. So if this condition is true, then you begin, and the break statement will be executed. Just as in a switch case, the break will terminate the execution of that switch. The break will take the control away from the switch. So also the break here in the for loop we make execution of for loop to terminate. It will break away from for loop. The program will break away from for loop, will not do anything with for loop any longer. Anytime the condition of the break is satisfied. So for example, if you want to print 1 to 10 and the condition is when um when when your variable is equal to 4, break. That means that it will print 1, it will print 2, it will print 3, but when it gets to 4, it will just break out of the loop, and also it will not print anything again. Or if you want to print odd number, you want to print all the odd numbers from 1 to 100, or all the odd matric numbers, so or all the odd numbers from 1 to 100 or 1 to 10, anything. So you know the condition for odd numbers, that we are going to make use of the the remainder operator modulus. So the number you are in, modulus 2, if it is equals to 0. So for the case of odd number, it doesn't break doesn't actually fit in the case of printing odd number or even number. So we are going to do another one that fits in perfectly into that. So what we have for break is when you want to stop initialization, when you get to a particular condition. There is another condition that you are looking at, and when you get to that particular condition, you want to stop the loop, the iteration of the loop. So that's when you use break. So break will stop with the iteration of the loop. Now the other one, that one will fit in very well into into what we want to look at. So that is the third one. It will fit it well into printing of odd number or even numbers. So we can say, so this is for loop. So this is for loop with continue. For loop with continue. So this for loop with continue, what will happen here is that you have your if and you have a particular condition is equal to true. So you have your if and particular condition. So then you have you begin, then you write continue. So continue. Then you don't forget your semicolon after continue. So then you end the continue. So what will happen here is that as when you want to print odd numbers from 1 to 100. So and the condition for odd number is that when you divide them by 2, there will be a remainder. So that means that those things that you want to print, if they have remainder, if they don't have remainder, you are not going to print them. So you want to print numbers that when you divide them by 2, they will have no remainder. They will have remainder. You don't want to print the one that will have remainder. You want to print, you don't want to print the one that will not have remainder. That is even number. You don't want to print the one that will have, that do not have remainder. That is even number. That the remainder will be 0. So you don't want to print the one that the remainder will be 0. You only want to print the one that has remainder that is greater than 0. So you will now let your condition be that maybe x, when x modulus 2 is equal to 0, you continue. What it means is that you skip that number. So when you get to 2 now, to 2 modulus 2 is equal to 2 modulus 2 is 0. So that means that it will skip the printing of 2, and it will not print any statement for 2. It will now modify this the loop, and the modification will now become 3. So it will now check the terminating condition whether it is satisfied, and we still remain 1 to 100 if it is true. We move inside the loop, we check the condition. Is 3 modulus 2 is it equal to 0? 3 modulus 2 is not equal to 0. So it will not execute any, it will not execute the continue. it will now execute the statement after the continue, and that statement is outside the if structure, and the statement is that you will print that particular number. So we are going to see the execution in the next video. Now, another type of for loop that we have is nested. We have the nested for loop. So this nested for loop is when you put a for loop inside another for loop, like your nested if. So you have your for loop and you will put another for loop inside it. We have another for loop inside it. So that is what we mean by nested for loop. So having a for loop inside another for loop, so it will give you a nested for loop. So if you look at it now, you see that this one is inside this one. So this is the body of the first one, and this is the body of the second one. So when you have an if statement inside another if statement, so that's what we refer to as nested for loop. And we have situation where we make use of nested for loop. For example, when we want to do multiplication table and things like that, then you make use of nested for loop. So these are the I think nested for loop is number what now? It's number 4. So these are the 4 types of for loop that we want to look into. So in any language, this is the syntax for it. There is another one but is beyond the scope of this class, and we are going to look into when you are doing your Java, they will teach you how to